Good morning, everyone, and welcome to today's webinar. My name is Keira Proctor, and I'm the Managing Director of the A. Proctor Group Limited. Today we're going to consider ground gas protection. We originally ran this webinar back in May 2020. Today, though, we also have a special guest, Paul Colbeck, Chair of the British Verification Council and an expert on gas protection system validation. This is a little more specialised than some of the topics we've looked at so far, but it's never a bad thing to have a broad understanding of the full spectrum of factors affecting building design. In today's presentation, we'll be looking at the sort of contaminants that you need to consider protecting against and what sort of impact they can have on the building occupants. We'll also consider the relevant legislation and guidance available to designers, and then take a look at the practical issues around installation of gas protection systems and some of the common problems that can arise. We'll finish by taking a look at the systems available and the types of projects these are best suited to. The first contaminant we're going to look at is methane gas. Methane is a naturally occurring gas which mainly originates from the decomposition of organic materials. This gas production is most commonly associated with landfill sites, but peat bogs can also cause elevated levels of methane. Naturally occurring methane is colourless and odourless. Over the long term, any exposure to methane at concentrations over 1% can cause impacts on well-being, such as headaches or dizziness, and can cause difficulty breathing at higher concentrations. The problem most typically associated with methane contamination, however, is the risk of explosion. At certain concentrations in air, methane becomes explosive and will readily ignite. The upper and lower extents of this concentration are referred to as the upper and lower explosive limits. For methane in air, these are 15% and 5%, respectively. Below 5% concentration, there is insufficient methane present to fuel an explosion, and over 15% there is not enough oxygen present for ignition. Concentration out with these limits should not, however, be regarded as safe. The most widely known incident arising from methane ground gas is the Abbeystead disaster, which took place in 1984 at an underground water pumping station in Lancashire. This was the first real disaster caused by ground gas, which helped start the ball rolling in relation to the guidance and legislation which we now have to follow. Methane, which had seeped into the building from coal deposits deep underground, ignited and destroyed the facility during a guided tour for local residents. At the time of the explosion, there were 44 people in the building. Of those 44, 8 died instantly and 8 subsequently died due to their injuries, sadly. Subsequent inquiries and appeals found the building designers liable for the accident by failing to exercise reasonable care in assessing the risk on site from gas ingress, highlighting the importance of death studies and site investigations when dealing with potentially contaminated sites. Fortunately, there have been very few other cases of methane explosions in buildings in the UK since. Carbon dioxide, or CO2, is another naturally occurring ground gas, most commonly originating from disused mine working, where pockets of gas may accumulate. CO2 is an asphyxiant, as it typically reduces the concentration of oxygen in the air below critical levels. From 1% concentration in air, CO2 will begin to cause headaches and drowsiness. 5% will begin to induce sleep or loss of consciousness, and 10% will lead to oxygen starvation, suffocation, and death. High concentrations can cause sudden loss of consciousness, meaning victims may be rendered unable to escape before they even become aware there is a problem. A recent example of CO2 problems occurred at Gore Bridge in Midlothian. In this case, site investigations revealed the presence of former mine workings under the site, but detected relatively low gas levels, therefore no requirement for gas protection measures. However, when housing was built on the site, incorrect foundations were used, and this, combined with construction of a nearby railway line, disturbed the ground and released high volumes of gas from the mine workings. It's also possible that the investigation boreholes themselves may have contributed to the release of gas from the mines. Combined with the period of exceptionally low atmospheric pressure, this CO2 entered several properties on the site, causing various health problems for residents. In some properties, concentrations of up to 20% have subsequently been detected. The severity of the problems, combined with the difficulties in retrofitting adequate gas protection, has led to a number of these properties being demolished, causing both significant cost to the local authority as well as extensive disruption to residents. The fate of the remaining affected properties is currently uncertain. Of all the common ground gases, radon is considered the biggest killer, with Public Health England estimating around 1,200 radon-related deaths per year. Radon is a radioactive gas produced by the underlying geology of some sites and is associated with the development of various cancers. Everyone is exposed to radiation from a variety of sources at all times, and in the UK, the largest source is natural radon ground gas. That being said, typically, these low levels of exposure do not cause any problems. The trigger level for dangerous radon exposure is 200 becquerels, and this can be reached where ground-produced radon gas concentrates in enclosed spaces. For comparison, the background level of radon activity is around 8 BQ. Radon levels will change across the country as it depends on the geology of the area, i.e., where granite is prevalent as the underlying rock. Radon maps are produced to indicate where the underlying geology is likely to produce significant amount of radon and require protection to be provided to any development. In the white areas on this map, it would suggest that no protective measures are required, down to the darker areas where barriers and/or ventilation would be necessary. A word of warning with these maps though, they are based on the underground geology and historical readings, but may not accurately reflect the precise situation on site, or how the development itself may have altered the pathways for gas flow. Current radon protection measures allow the use of a basic 1200 gauge polyethylene membrane, such as would be used for damp proofing measures. Whilst this may be able to resist the permeation of radon, the ability of the membrane to withstand the build process must be considered. The approach to dealing with these types of contaminated land is based on the concept of pollution linkages. The primary linkages present in every situation are the pollution source, the pathway, and the receptor. This source, pathway, receptor model forms the foundation of risk-based design strategies for ground gas and VOC contamination. Source treatment involves taking action to break the linkage at the source, the actual pollutant itself. In very simple terms, this involves achieving one of the following outcomes: destruction, neutralization, whereby the pollutant is rendered harmless through the use of some form of treatment, such as adding a degrading chemical agent or a process such as heat. Removal, which can entail either removal of the polluted soil and disposing of it off-site or extracting the pollutant from the soil. Immobilization, or trapping the pollutant by adding chemicals to solidify the contaminants, making it impossible for the liquids or vapours to escape. Pathway. A pathway management solution breaks the link between the contamination at the source and the building occupants by two primary means. Barrier systems, which physically block the passage of harmful liquids or vapours either at the source or the receptor. Dilution dispersal, where ventilation systems are used to reduce vapour concentrations below harmful levels. Ensuring barrier and ventilation systems work effectively over the lifetime of the building is critical. Both specification and installation of these systems is more complex than it may appear, with an array of physical properties, tests and installation details to consider. It's also not advisable to rely on the membrane to provide 100% barrier to contaminants, so these systems are often used as part of a wider-ranging remediation strategy, particularly on heavily contaminated sites. Receptor. Receptor management is the most problematic of the three strategies, mainly as it can come into direct conflict with the purpose of the building or structure by placing restrictions on the occupants which may prove unacceptable. For this reason, receptor management is most commonly used only as a temporary measure, while a longer-term strategy is developed. For example, restricting access to buildings during decommissioning of an industrial site, or evacuating residential properties in response to a nearby chemical spillage. Another more common example of receptor management would be health and safety requirements placed on contractors during remedial works, such as PPE or safe working practices. Gas protection legislation. There is a great deal of legislation and guidance available in this area to cover all aspects of the source pathway receptor model. In today's presentation, we'll be focusing mainly on barrier systems, so the pathway management part of the model, and the legislation which is dealing with that. CIRIA 665. CIRIA 665 forms the underlying basis of gas design by classifying contaminated sites into what are known as characteristic situations. These classifications, from the least contaminated CS1 up to heavily contaminated CS6, are based on detailed site investigations typically undertaken by specialist consultants. Once the characteristic situation has been defined, further guidance can be referred to determine the most appropriate gas protection measures to specify. BS 8485. BS 8485 is a code of practice for designing new buildings and conducting risk assessments on proposals. It was originally used in 2007 and it was a 28-page document. However, after a revision in 2018, it has now grown up to about 100 pages. BS 8485 bases its guidance on site classifications from CS1 to CS6. A CS1 site has no gas present, while CS6 sites are heavily contaminated, almost to the point of being unsuitable for development. The site classification is then cross-referenced against the building's risk category. Type A buildings are domestic structures with small rooms and limited air movement, thus having a higher likelihood of gas building up to a dangerous level and increased exposure for occupants. At the other end of the scale, Type D buildings such as warehouses have large volumes and poorly sealed or frequently open doors, leading to lower concentration of gas in the internal spaces. Buildings of these types are generally less continuously occupied. This assessment produces a point score for the building and site combination, and this sets the level of gas protection measures that must be applied. The first area in which points are allocated is the base construction of the floor and substructure. A poorly sealed element such as beam and block floors will score no points, while 2.5 points are given for a fully tanked waterproof basement. The main issues here are in the middle case, slabs with minimal penetrations. The degree of acceptable penetration is poorly defined by the standard, leaving it largely up to the designer what point score is acceptable. Further points are awarded based on the underslab ventilation provided, which can be either passive or active. The most basic form of ventilation is a pressure relief pathway, but little guidance is available on the degree of performance and robustness required. Beyond this are passive dispersal layers, which are classed as either good or very good based on how well the gas is dispersed within the layer. The passive systems rely on gas pressure, atmospheric pressure, and wind pressure to drive the gas flow out of the underfloor spaces. If properly designed and maintained, the passive nature of these systems make them less prone to failure than active systems. Active systems use powered fans to remove gas, which in theory makes the systems more consistent and potentially more effective at removing gas. But problems can occur if fans are switched off for any reason, such as during change or tenancy or sale. For this reason, the points associated with active systems were reduced by the 2018 amendments so that in most cases additional passive protection would be required. Finally, points can be scored by a properly specified and installed gas membrane. Again, the guidance has been made tougher with the new revisions, and in order to score points, the barrier membrane must fulfil all the listed criteria. This ensures all membranes used on site are of sufficient quality and are properly installed. Under the old guidance, barrier membranes could score points under BS 8485 without providing any actual protection in practice. This could arise as much from damaged membranes or from poor workmanship sealing joints as from low-quality material. NHBC Traffic Lights. The NHBC uses a traffic light system to remove ambiguity from the classification and streamline the process. This is not intended to remove the need for specialist assessment, but rather to simplify the implementation of measures based on their findings. A green site is roughly analogous to CS1, and no special protection measures are required. Amber 1 sites align with CS2 and can be dealt with by using a simple membrane and passive subfloor ventilation system, as the risk is comparatively low. Amber 2 CS3 sites, being higher risk, require a specialist contractor installed membrane with additional verification of the membrane integrity. Red sites are generally considered unsuitable for private housing developments, and if built on at all, will require a more in-depth and specialised approach. A requirement of BS 8485 is that the membrane installation be verified in accordance with CIRIA 735, another important document for designers dealing with gas protection. Released in 2014, C735 details requirements for validation and inspection and means that more or less every gas protection installation will require fully independent inspection and verification of at least some percentage of the development. This CIRIA document also details the types of testing that can be undertaken, from simple visual inspections through to air lance and tracer gas testing. Not all of these testing methods are suitable for every site, and these limitations discussed in the CIRIA documentation, making it well worth reading for anyone involved in these types of projects. The purpose of mandating this testing is to ensure the systems as installed will perform as designed, and ensuring that performance is maintained throughout the design life of the installation. The requirement for inspection can be reduced if NVQ Level 2 installers undertake the job, so in this way CIRIA 735 aims to upscale the groundworks installation industry by reducing the associated costs of verification and inspection to offset the expense of installer training. A further consideration, dealt with primarily via CIRIA documents, is VOC contamination. VOCs, or volatile organic compounds, are defined in CIRIA 716 as organic compounds that are volatile under normal environmental atmospheric conditions. They may be found in the ground in the solid, liquid and dissolved phase form, as well as in gaseous phase. VOCs can be both man-made or natural and have a wide range of applications and sources, being found in everything from paints and coatings to plastics and cleaning products. Hydrocarbon fuels such as petrol and diesel are also forms of VOC. When specifying geomembranes for VOC applications, it's important to remember that chemical resistance and vapour permeability are not the same thing, and membranes that are highly resistant to liquid VOCs may not be suitable in a VOC vapour barrier application. Conversely, membranes which resist VOC vapours effectively may lack the resistance to be used in the presence of liquid hydrocarbons. That's not to say the chemical resistance is not important, as the barrier must be able to resist exposure to adverse conditions in the longer term without negative effects to its performance or mechanical properties. It can't always be guaranteed that the VOCs will remain a vapour, as the water table may rise and bring the membrane into contact with VOCs in liquid form. The actual VOC resistance is only one facet of membrane performance that must be considered. The CIRIA 748 document gives important guidance on the specification of membranes used on VOC contaminated sites. Membranes must also be able to resist degradation processes such as oxidation, particularly if they are based around foils. Once again, there is a series of linkages that must be considered as the basis of good, robust design. Foil membranes are often considered to be a perfect solution as they offer high resistance to all types of vapour, but it must also be taken into consideration that the foil responsible for this resistance can degrade or break down over time. It's not uncommon for a membrane to pass the vapour permeation test, then subsequently fail due to degradation association with oxidation, where vapour has permeated through the cut edges of the membrane. As part of an appropriate overall design, a membrane of lower resistance to a liquid contaminant may still be suitable provided exposure to that liquid form is minimised, for example by means of source remediation or by ensuring the barrier is located in the structure such that contact is impossible. We'll now move on to take a look at some common installation situations and the difficulties that can arise with each. We'll begin with corner details, which are probably the most common detail present on every site. This corner has been cut and resealed using flashing, but has been left unsealed at the corner. The membrane has also not been pushed into place properly, so any subsequent concrete or screed pours will overstress the membrane, which may lead to tearing and subsequent gas ingress. In this case, the membrane has not been extended to close the cavity wall, leaving open a pathway for the gas. The membrane is also roughly folded into place, which may cause problems when it comes to installing further courses of brick or blockwork. The most reliable and time-efficient method of getting a good corner join is to use preformed corner units. In most cases, however, these corners will need to be adapted to fit precisely into place. The important part of the corner, the integrity of the actual corner point itself, can be maintained by carefully cutting the corner unit across the middle and sealing both the top and bottom sections into place as shown here. This ensures the corner area remains fully gas tight. Another detail found everywhere is the simple membrane joint. Apparently simple enough, joints between adjacent runs of membrane commonly cause problems. The most obvious problem is the missing sections of sealing tape, creating a path for gas to bypass the barrier, but tape joints can cause other problems. Here we can see that the tape run has not adhered to the membrane where the membrane is not sitting flat on the substrate. The most effective method, and that used by the majority of NVQ2 qualified installers, is to weld membrane joints. This not only saves on the cost of tape, but it's far more tolerant of weather and site conditions as tape adhesion is not an issue. Successful tape jointing requires a clean and dry membrane surface to joint, and temperatures within the tape's operating range, typically 5 to 30 degrees. Detailing around stanchions is a little more difficult, but does not pose too many problems if the method shown here is used. The most important thing to note here is that the flashing tape used is of good quality and matched to the membrane used. As manufacturers, we recommend and supply tapes that we know to work well with our membrane systems, and this advice should be followed. The flashing tape should be rolled into place without leaving gaps underneath. Flashing tapes are usually less resistant to elongation than membranes, so it's important these areas are fully adhered to a properly supported substrate to limit the potential for movement. The rounded corners shown here are also important, as these are less likely to lift than a sharp corner and put less stress on the membrane and tape interface. Although it may seem obvious, it's also important to ensure the gas-tight layer is continuous. If, as shown here, the stanchion is in the centre of a concrete column or pile cap, the entire area must be sealed. Pipe penetrations are another area it's important to get right, as they are a common feature on many sites. These are images shown of the more common problems that can occur. In the first case, the supply top hats did not fit properly, so the installers have got a little creative. While it's possible this detail may work to provide a gas-tight seal, it's by no means a given and would almost be impossible to verify. In the second, the smaller pipe appears to have been relatively well sealed, but the larger is not sealed at all and corresponds to a lap in the membrane, creating additional complications. The close proximity of the pipes to each other also makes detailing and sealing using proprietary top hats difficult. Here we can see the correct procedure to provide a gas-tight seal to a pipe penetration. As with columns, this is not particularly difficult to achieve. Again, as with stanchions, ensuring the membrane is cut as little as possible and the top hat is smoothly seated onto the membrane is critical. The flashing tapes should be firmly adhered in place and properly supported. The general conditions around a site are often as important as specific details when it comes to validation of membrane installations. In these images, you can see that patches have been applied to the membrane haphazardly and messily. The marker spray is still visible around patches, indicating that the applied patches are too small to give the required overlap. In this case, we can see the rebar laid directly onto the membrane with no protection fleece or board used. The fleece is not only important to prevent direct puncturing of the membrane, but also to prevent damage from cutting using saws and grinders. These processes produce large amounts of sparks which, if they contact the membrane, can melt holes and cause significant damage. So while a small increase in cost per square metre to specify a fleece or protection board may seem unnecessary, the effect it can have in reducing remediation costs and delays is more than worth it in most cases. So we've seen throughout today's presentation that the most important factor in detailing with contaminated sites is good design based on good and accurate information. Whether it's conducting a thorough investigation into the historical uses of the site or ensuring the correct membrane for the job is well installed by contractors, a good understanding of the risk factors involved and a well-developed holistic remediation strategy is key to achieving a safe and good value solution. We'll now follow up with a special guest presentation from Paul Colbeck before moving on to our Q&A session.
Hello there, my name is Paul Colbeck. I'm from the British Verification Council. I've been in construction for over 30 years. Started out as a young engineer running around in his underpants to becoming a project manager on some pretty large projects. I moved into waterproofing for an American company and I managed to travel all over the world. This involved training, consultancy and quality assurance. In 2015 I joined GeoShield and brought these skill sets into ground gas validation and verification. I'm an assessor for the NVQ2 and I'm also an assessor for the NVQ4 in verification. I'm the current BVC chairman and I'm also assessor for the new CLEAR accreditation scheme. So, verification. Any ground gas protection system is only as good as the design and the installation. Sounds simple, but how many times doesn't it happen? Today, I will cover two aspects of verification: why we verify and the progress of verification and the organisations that have contributed to this. So why we verify. Poor installation of gas systems could result in death. We've had examples over the last 10 years. Every year at Radon Awareness Week, we get bombarded with this 1,100 deaths per year as a result of radon. That hasn't changed as long as I've been in ground gas. So are we progressing with this? Question for debate. There is direct comparison to waterproofing. We don't validate waterproofing. There is a lot of leaks in waterproofing. Direct comparison. But waterproofing, you only get your feet wet. So why verify? Human error. You can have the best specialist out there, the best company out there, but they're going to have their off days, and that's why you need to validate to make sure that their off days are validated and the installation put right. As I say, ground gas can result in fatalities. Well, due to human nature, poor workmanship, it happens. And do we care? Well, this goes right down from the upper management, right the way down to the ground worker on site. Lack of knowledge. Well, I think with this one, this is why we're here today, but I think if site managers, project managers knew the ramifications of what they are doing, I think they probably would take more care. Program. Well, every project manager is always asked to do it in less time than he's been given. We've got the Friday afternoon scenario, which then runs into Monday morning. I don't want to be there on a Monday morning, and I want to get away early on a Friday. We have poor design, wrong materials, and shortcuts. We have good guidance in relation to verification at the moment. We have BS 8485, CIRIA 735, BR 211, CIRIA 748, and the new retrospective document covers verification very well. Progression of verification. Over the last 2 years, various organisations have been working to create standardisation within verification. More than any other aspect in ground gas protection, I think verification has got their house in order. We have the new NVQ4, which is equivalent to a degree, specifically for ground gas verification. We have the PCA starting to get involved in ground gas, and potentially with a equivalent CSSW in relation to ground gas. We have the PVC, which I'll talk about a bit later, and we have the CLARE accreditation and declaration. The CLARE accreditation helps demonstrate that a suitably qualified person under the National Quality Mark Scheme has undertaken the validation process correctly. So if any verification report is submitted and has the declaration, a local authority will immediately know it's of suitable quality. Standardisation of verification. We have these various organisations who are inputting now into this. We've got the BVC, we've got ABBY and the NVQ4 in ground gas protection systems. We have the PCA with their audited membership, and we have CLARE with the gas protection accreditation scheme. All of these organisations are now inputting into training. 2 years ago, there was no training for verifiers. Now we have all these organisations inputting into training as a regular basis throughout the years. Just going to talk about the British Verification Council now. The British Verification Council was formed in 2018 to create a specific forum for like-minded companies and individuals within ground gas verification to swap ideas and practices. The BVC membership is solely for verifiers, or companies with departments which have verification. In general, the feedback that we got was that gas system specialists, such as installers, required standardisation. What they found was verifiers coming to site, some with a magnifying glass and some spending 2 minutes on site and fundamentally walking away. What they want is standardization so they know what to expect. So primarily the reason the BBC was put together was to create standardization, to bring together like-minded companies and then use the BBC logo as a benchmark, as the standard for verification. So secondly, the BBC is an ideal forum to train and educate both verifiers and industry, using the expertise within the BBC. We can use in-house knowledge to assist our members and again create standardization. The BBC is an association for professionals, it's not a trade organisation. Therefore, is an ideal position to influence organisations and legislation, such as CIRIA. We were present on the new retrospective document, British standards, local authorities. We've done presentations for YALPAG, NHBC, warranty providers, and trade organisations. So, yeah. To become a member we realised fairly early on, we have to be robust. It's not just a case of plain subscriptions and that's it. So we created this, a rigorous profiling questionnaire has to be submitted first. Then an interview by at least 2 members of the BBC. And then we've now introduced that all members, to become a full member, you have to have the CLARE accreditation, which is the TGPV or the SGPV, which is the technician and specialist. And ultimately, if you have which is the ultimate goal, which is the MVQ4. Why verification needs the BBC CLARE accreditation, PCA and MVQ4? Well, this is a particular live example where a project manager in Scotland falsified his own reports. Well, with the BBC CLARE accreditation and MVQ4, this shouldn't happen because the qualification will be on the reports and local authorities can then look for this. So in summary, the ground gas industry should support these organisations as they promote standardisation and good practice. The BBC CLARE accreditation and the MVQ4 qualification provide a benchmark which the local authority, manufacturers, installers and contractors can use as a mark of quality within the industry. So this is what we don't want within the industry, and this is what we do want. So hopefully that was of help, and hopefully I'll be able to answer your questions a bit later. Thank you.
Good morning, everyone. Thank you very much for joining us today. Believe it or not, this is our 21st webinar since we started doing these last March, which now seems like a very long time ago. So I hope you're all doing well. We're enjoying an awful lot of snow up here, which is why I look like I've got a slightly white background. So we're making the most of having some fresh air when we can bear the cold. As you know, we will try our best to stay here and answer all of your questions, so we stay for as long as it takes. So please feel free to post them here in the YouTube feed, email us at webinar@proctorgroup.com or DM us on Twitter. If you'd like to request a product sample pack, which contains the materials that we're discussing today, or request a meeting with one of our technical staff, for example, or discuss your project, you can do all that now on our webinar page, which is www.proctorgroup.com/webinar. You'll also find on that page personalised CPD certification, which you can find available there. Just a date for your diaries, our next webinar will be 2 weeks today at 10 AM. So entirely new content and quite an interesting subject actually. So the topic will be spinning the golden thread, data management and data quality. So we have 2 special guest presenters, DAO CEO Mark Williams and Twin Edit Media Master Jodie Davies. So this webinar is essentially going to cover the use of a special platform to collate, manage and distribute complex building data sets, which will then be followed by an interview of the upcoming Construction Product Information Code consultation. So all around digital twinning and how that's catching up with physical twinning. So it's a really topical discussion point in the industry at the moment. So we hope you can join us for that. If you've registered today, you will receive a follow-up email with all the links that we've been discussing and a link to the replay. So please feel free to circulate that. Late registration is actually still open for this week's webinar if you want to use the webinar link just now, so you can utilise that. It really helps us if you give us a thumbs up on our video and subscribe to our YouTube channel. It also means that you'll see new content as and when we post it. Okay, so I'm just going to introduce the panel, some familiar faces. So if we start with Pam Howitt, who's our Senior Technical Advisor. Morning, Pam.
Morning, everyone.
Morning, Sue. Sue's also a Technical Advisor based up in Scotland.
Morning.
Chris Hayes is our National Technical Sales Manager for the ground gas sector. Morning, Chris.
Morning, everyone.
Good. And we had a quick introduction there to Paul, so I won't go over the same things again because we all saw it on the webinar. Good morning, Paul.
Hello there. Hello there.
Hi, Paul. So obviously Paul has a wealth of experience in the gas sector, along with the other faces that you see from the Proctor staff here. So we're able to answer all your questions. So we're just going to start. I can see a lot of great questions coming through on the YouTube feed already. We've had quite a number through email. So please bear with me while I'm trying to work through these different platforms. I'll try not to miss any. If we do, we will email you at a later date or today, of course, or I'll try and not miss any as we go through. Okay, so if we can start with a question for you, Chris, if that's okay, from Tom Fisher. So what is your advice when it comes to jointing VOC flex membrane? Is it okay to use tapes?
Okay, morning, Tom. Thank you for your question. Quite an interesting one, really. As proctors go, we really recommend that you weld hydrocarbon membranes. The CIRIA guidance, which is the CIRIA 716, is a little bit woolly when it comes to using tapes as a method of sealing, just for the nature of the restrictions that you have with tapes, such as dusty surfaces. Generally, hydrocarbon membranes are a bit more rigid, so not so flexible, and can be a little bit more difficult to tape. I think the other thing that we need to point out as well is that there's little evidence to prove that tapes are actually hydrocarbon resistant. So to be sure that your lap is fully secured when you're dealing with some of these nasty contaminants is the best way is to weld it. So at least you know when the membranes fuse together, the membrane's tested and certified, and therefore you can guarantee that you've got a seal at that junction. So really, that's why, as a company, we would recommend welding as a form of jointing it.
Okay, that's lovely. Thank you very much indeed. Paul, Craig has asked, when should the verifier be appointed?
Hi, Craig. This is I think a really good question, actually, because ideally this should be at the earliest possible stage. It doesn't really happen in reality, I'm afraid, but if the verifier is brought in at the earliest possible stage in the build process, the verifier can help validate the design, and also, look into the buildability. Also, they can look at, the verification procedures with the, with the design team, with the let's say the project manager, the client, the main contractor, the subcontractors that are involved. So if they are involved at the earliest possible stage, it helps in the validation process rather than the verification process. So
absolutely,
that answers this question.
Okay, thank you, Paul. We have another one here on the YouTube feed that's just come in from Colin around guarantees for house purchasers, if I can ask this one for you. So are installed systems verified by certification or guarantees to protect purchasers, e.g., NHBC house purchasers or non-NHBC purchasing?
That's a great one, that one. Well, to my mind, I mean, on behalf of a verifier, all we do is validate the installation. Okay, we don't give a warranty. That's not our job. Our job is to make sure that the installation is installed in accordance with fundamentally BS 8485 and CIRIA 735, specifically Table 7, which states it has to be independent. Now, a verifier will not issue a warranty. NHBC, they issue the warranties. Premier, they issue the warranties. Typically, what we would like, and it doesn't really happen in gas proofing, but it does happen in waterproofing more, is that the installer will issue an installation warranty. But it doesn't really happen in ground gas installation, I'm afraid. So on behalf of verification, we do not issue a warranty. Okay.
Thank you, Paul. Thank you very much. Pam, James has asked, what is your advice, when using vent mat down a battered angle of the slab edge? Does this affect its venting performance?
Yeah, it's a great question. You kind of think, oh, just sticking a mat for ventilation, it'll be no problem at all, just take it across it. But you have situations like we've come across on site where you may have quite a large step down from one side of the building to the other. So that could be a problem because that might make that slope very steep and impractical to actually build on site. This is where it comes into what Paul said earlier about the buildability of a design. Also things like architectural features like bays or external block work around like that, all of that can impact on it. So really what you want is you don't want to sort of come across and then suddenly do sort of like a right angled step down, because you could have issues with the flow rate there. You want that pathway to be as unobstructed as possible. And it's best to try not to fold it too much. You want a gentle slope if you can. So it may be possible, or it may be actually better to take the location of that mat and maybe move it further down in the construction and then sort of put some sort of void filler above it. So you've got that dilution path, you've got that entire site capped off from gas coming up, but you've got a situation where you can actually provide that ventilation across that whole footprint. Again, it's really important to let us know if you're coming to us for options as to the sites, to let us know if there is a property or a couple of properties in site that fall into that type of scenario.
Okay, great. And Pam, if I could ask you another, please, from Philip. What is the guidance on closing off cavities and linking gas membranes into DPC cavity trays?
Yeah, so it's really important, and there's no point in putting a gas membrane and stopping it at the inner leaf of your building, because you've then got a cavity where gas can seep into and go right back into the building. So really you need to take your ground gas protection right the way from external wall to external wall, all four sides, or how many sides your building has, and make sure those cavities are closed off. Now that can either be done with gas resistant DPC, a starter band like in our system. It could be that you can also use a gas resistant cavity tray, but they all do have to be linked together, and you should be able to almost like draw that line, similar to what we talk about in the air tightness, but draw that line right the way across the base floor to ensure you've got everything closed off and there's no leaks into the main building.
Okay, that's great. Thank you very much, Pam. So Sarah has asked, why are some sites classified using a traffic light system, whilst others are CS1, CS2, or a point score?
Okay, so we did kind of actually go over this in the webinar, but the traffic light system has been adopted by NHBC, usually for obviously residential buildings, building type A, and is followed where methane and carbon dioxide is present. The process of actually categorising is exactly the same as Wilson and Card method, in that you have to work out obviously your gas screening value. And this is taking the highest concentration, of the gas at present and the greatest gas flow rate. And from that you work out your gas screening value. With NHBC, it's quite visually represented in the traffic lights. So it's red, amber 1, amber 2, and green, or the other way around actually, green, amber 1, amber 2, red. So it's an alternative way of classifying the site and deciding on what level of gas protection is actually required.
Okay, that's great. And Sue, if I can come to you, and we've had one via email as well. I know there's a lot on the YouTube feed, and I will get to them. But Joel's mentioned, and this is a question we've had actually on a lot of our products. I purchase a lot of your products in the south of Ireland. How will Brexit affect this and the CE marking?
Okay, yes, so Brexit. Yes, I mean, we'll still obviously be able to supply all of our system components throughout the UK, throughout Europe as well. They're currently CE marked to European standards, and there's, that will remain in place. Currently, the current CE marks are valid until January 2022, so we have till next January, and at that point we'll then have introduced the new UK CE marks for the products as well. So basically, we'll be able to supply in Europe and the UK, and our testing certifications and reports, etc., will be valid for both options.
Okay, that's absolutely fantastic. Thank you very much. Paul, if I can come back to you, please, for one. I've received another one via email from Miles. How, as a verification company, do you protect the gas membrane against other trades?
Thanks, Miles. I think this is a verification company. A lot of this can be done at the earliest possible stage again. And we typically do this by a pre-verification plan. And you can identify the hazards associated with a particular design, because each project is different. And some will specify, protection board, which is a lower risk. Now, that's relatively easy, but a lot of the current projects, they won't specify a protection board. So we can identify in the pre-verification plan, which will extend to a pre-verification meeting with the other subcontractors that are involved, like steel fixers, concreters, to say, well, look, you've got a not very robust membrane here and you're throwing steel about. So at that particular stage, we would really try to protect the gas membrane at the pre-verification stage. That's really, I think, the only subsequent measures that we put in place. We put signage in place, which will show to the subcontractors who walking around, so there's subsequent walkway, so they don't walk over the membrane. But I think pre-verification plans and pre-verification meetings are the way to protect ground gas systems.
Okay, that's great, thank you. Chris, I'll ask you this question from another Chris. There were some examples of bad practice around difficult junctions, steel columns, etc. What do you recommend as a technique to make these junctions easier to deal with?
That's an excellent question, Chris. To be fair, really, there's a couple of ways of looking at it. To help reduce the risk with any sort of poor detailing on site, particular complex junctions, I suppose this is where really why we look at using specialist installers that are trained to deal with these types of details on a daily basis. So that would be one sort of option, is actually get somebody who is skilled in detailing these types of junctions. Alternatively, we can provide preform units that can sort of mask these or cloak these difficult junctions, which obviously assist people that's probably not got the skill as an installer. So if you have that situation and you want to tackle it yourself, then we do have a range of details and a range of products that we can sort of assist with the detail to make it a sound one.
Okay, that's great. Thank you very much. And Chris, if I can come on to another one, which is quite specific from Hannah, please. Why does BS 8485 ask for a thickness of not significantly less than 0.4 millimeters and weight of 370 grams per square meter for gas membranes? Do you feel this is a relevant statement when looking at robustness of membranes?
That is a really good question, actually, Hannah. And it's a question really that we sort of rose when the British Standard document came to public comment. I think what we have to be aware of is that there's obviously many square meters of robust gas membrane has been laid over the last 20 years and not necessarily had a weight constraint. So really, I think what we need to look at when we state a weight, it would be good to also have an actual tolerance figure, so something like plus or minus 5%, rather than saying significantly less, because that leaves it quite ambiguous, because what is actually significantly less. So it would be good to have a figure against the weight. But again, you shouldn't really be looking at just the weight as a limiting value, although it does actually improve things. It does improve the industry by looking at the weights of membranes. But when it comes to robustness, you really need to consider other things such as tensile strength, puncture resistance. So by just allowing weight, it can allow recycled materials and unreinforced membranes to be used as gas membranes, and generally without the reinforcement in them, that does reduce things such as tensile strength and tear resistance and so on. I think we also probably need to get across that the British standard is not a material specification. You know, it's a form of guidance. It's the designer's responsibility to justify the choice of the membrane in a design report. And when you look at robustness, there's lots of things that has to be considered. So the position of the membrane, is it going below a heavily reinforced slab, for example? So therefore, there's the likelihood that it could get damaged through the construction process. So when we talk about weight and thickness, it has, although that's within the British standard, robustness as a whole has to be taken as a complete factor. So there is a good document actually that the Environmental Protection Group that Steve Wilson has put together, which is to do with gas membranes and compliance with BS 8485, and it talks about all these things and of what, you know, membranes have to be to sort of classify them as being robust. So does that, I hope that answers the question.
It does. And while you were just talking about installation there, we've had one in via email from Tom regarding the placement of these membranes. So when using a membrane to eliminate gases rising into the property, say radon, where is this membrane best positioned for practical and effective installation?
I think, you know, with regards to the placement of it, it should always go above the venting. So whether that is a radon sump that you're putting in for solid floors, or whether you've got a beam and block floor, you know, really essentially you'd be positioning it above the membrane. Things again to consider with positioning the membranes, if you're going to put it beneath a slab, for example, is potentially differential settlement of the slab. So it's generally a good idea to rest the slab on the inner leaf so that it kind of suspends it, so it then prevents any rupturing of the membrane at the perimeter that could happen if you have that differential settlement. Another good practice is to make sure the substrate's nice and clean and supports the actual membranes. So, you know, a good example is using a 50 mil sand blinding below a slab, for example, because that would then obviously mask all of the sharps that you would get by using hardcore as a subgrade. Also as well, it's important to think about protecting the membrane as well. So, you know, if you're going above a beam and block floor, generally you would have an insulation and screed on the top, so the insulation would protect the membrane, whereas below a slab you may not have insulation at that point. So again, you might have to think about a protection board or fleece to sort of prevent damage to the membrane as well. So there's lots of factors you have to consider, but principally you want the membrane above the venting, and then obviously consider the things that I've pointed out there as well.
Great. And Chris, just one other thing. We've got a rocker in the house. So Rock City Nights, who's Google's linked to his band account, has posted a question. It looks like something you might want to follow up afterwards, but I'll read it out anyway in case you want to make comment. So what length does a passive vent mat become ineffective, and does points on 8485 reduce accordingly?
When you look at venting, when you look at using a vent mat, really it's only suitable up to a CS3 level. So that's something that you would also have to take into consideration is what the sort of level of gases are on that site. So you might have to look at a different type of venting system than a passive system anyway, for your gases. But ultimately, you know, you always want to try and put the vent mat on the short span of the building for that reason, because, you know, if you've obviously got 40, 50 metre lengths of building, then essentially, yes, it's going to cause inefficiency with the flow of the gases through the vent mat. So again, it really depends on what type of building you're dealing with, what sort of room sizes there are. There's lots of different things that we have to sort of take into consideration when looking at venting. And like I say, it is probably one that we could elaborate a little bit more on afterwards if there's a specific project that they've got in mind. Was it AD, did you say?
Yes.
Yeah. If AD's got anything specific, project he wants to talk about, then send that over and we can discuss all those sorts of ins and outs. It's quite a long process, okay. I suppose.
Great, thank you very much. So keep the question coming. I've got a little a number about verification, Paul. So I'll come to you after I've just clarified something with Pam quickly. There's 3 or 4 for you, Paul. So I've been saving them up so we can get through them. But Pam, I'm not quite sure if you can help me with this one. Greyhan has asked on the YouTube feed. I'm not sure if it's a statement or a question. In regards to radon detail for a timber frame building, so timber frame fixing 2 to 5 below sole plate, which also has level access front and back and external paths around the house. Is that something, I'm trying to figure if he's commented on that with regards to something else we're speaking about, or? Yeah,
possibly with that one point, it might relate to a point within the presentation they need to go back, but
right, okay.
Certainly, if it's a specific question, please drop us a line afterwards and we can, help you with that. Timber frame's always going to be an issue. It's not like brick and block where you've got it building up and you've not got fixings. You're always going to fix that sole plate down through. So we have tapes to mitigate that risk. So I've just noticed it's just popped up in the live feed there that emailed a detail to Sam. So we'll get that. We'll talk through specifics on that one. I think it's probably the easiest way to handle that one.
Okay, perfect. Right, so Paul, we have some verification ones. First one via email, and then we'll come on to the couple on the YouTube feed. Thomas has asked, do verifiers have to hold any specific qualifications in order to verify?
Officially, they don't. That's not written into CIRIA 735. It doesn't appear in any guidance. But as in the presentation, this is what we're trying to introduce for good practice and standardization, which is done through various organizations like the BVC and CLARE and the PCA. So we're trying to make it so local authorities are using the CLARE accreditation and the NVQ4 and the BVC, to be honest with you, that they will look to those as a standard. The first piece of guidance, which does have reference to the CLARE accreditation and the NVQ4, is the new CIRIA retrospective document. I think it's CIRIA 795. So it's starting to come into guidance now that it is good practice to have these qualifications or accreditations. Ultimately, that's what we want. Like a little bit like the NVQ2 for installers. If you're certain classification VOC, for instance, then you've got to be NVQ2. And what we'd like is verification. let's say even at CS3 and above, and VOC, you've got to hold these qualifications or accreditations. So let's hope that helps.
It does, thank you. Peter Henderson has asked, hi Peter, does the verifier verify or validate the gas protection design?
Well, I would say this is quite a contentious question, actually. Answering on behalf of GeoShield, we validate and verify. You can take this directly back to Grenfell, because in Grenfell and the instances that happened there, everybody was held to account. Even the firemen were held to account for some reason or other. So you are a professional, and you are using your skill sets to verify. So you are preparing a pre-verification plan. So you must understand what's going in that pre-verification plan, and you are giving advice to your client. So fundamentally, you are validating the design. So if something does go wrong, then you got to say, well, you gave advice to the client that this was all correct, and you have validated that membrane, and hopefully that membrane is the correct one. So personally, GeoShield, and I know there's a few other verifiers that are within the industry that are well thought of, think that validation is a key part of the verification process. It has to be.
Good. Okay.
Yeah.
Thank you very much. Pam, sort of a good one for sensitivity that a lot of sites have had in terms of delays because of lockdown, etc. So Rory said, we have a project that's been delayed for some time now. We've had a site investigation report done a few years ago. Would this report still be relevant? And do they have a time limit of how long they're valid for?
It's a good one. There's a lot of our technical director's favourite words in here, depends. In theory, if you've got a site that you tested a while ago, any historic data should get better, i.e. the gas will sort of reduce, won't be maybe so much produced, maybe venting off. So you would think that, for example, something that was maybe investigated 10 years ago shouldn't be any worse than it is now. I mean, it might be even slightly better, but you've got to be very careful. So we sort of take the example of like two fields next to each other, both designated for developing houses. Gas report, site investigation carried out 10 years ago, showed some methane there. If those two plots lay empty with nothing done, then you would think it should be okay. But if one of those sites got developed, what we don't know is how that work that went on in that area, or for that matter, new roads going in or other things elsewhere, how has that affected the gas pathways and the sources? Has it opened up other pockets that might not have been there? So really what you would want to do in that situation, what you should do if you're responsible, is look at getting some further rounds of testing done to assess that. I mean, really, from our point of view, we want as up to date information to look at as possible. I'm going to throw this over to Paul. I don't know whether he's got any thoughts from a validator's point of view or verification point of view, whether he feels that there's a time limit on investigation reports.
On verification reports, not really, because we're pretty live. When we do a verification report, long as the client pays the bills, we will then submit it. I think the only thing that becomes apparent, which we are doing a project at the moment where the contractor is wanting to lay 20 plots in advance, the perimeter works using a gas resistant DPC. Now he's not covering those up at all. So how long? You've got two elements here. Is the product going to withstand the UV impact on that material? Is it going to degrade? But then we've got the problem of, well, look at the weather we've just had. Is it going to survive the installation process? So then that report that we've done, say, even a month ago, is not valid because we've got to go back and reassess that perimeter install. So in that particular instance, and this is why in the pre-verification plan we will say, look, everybody wants that. As soon as the install is done, you get the concrete over the top, or you get the bricklayers on there as soon as you possibly can. If you leave it for any period of time, then it's going to get damaged. So that's in relation to verification, I think.
Okay, thank you very much, Pam and Paul. So Sue, if I can come to you, please. I haven't spoken to you for a while. Quite a long question sent via email here from Jeff. So under BS 8485, my site only requires the ventilation aspect to be of good performance. I've been quoted for Provoid in strip format. However, it's been suggested that I use a full blanket instead. Why would I do this, as surely this would need more material and cost?
Okay, good question. Under 8485, then strips of Provoid will meet the requirement for good performance for ventilation, achieving you in most cases 1.5 points. However, depending on your actual build and the ground conditions, etc., it might actually be cheaper and easier to install a full blanket of Provoid of your venting mat which will then achieve you 2.5 points. And that is really just to negate the requirement of your gravel. When you're installing the venting mat in strip format, you do actually have to dig out. The strips are interleaved into 200 mil of clean stone. So the difference between, sort of like the time involved and the cost of the gravel, you might be cheaper and quicker and easier just using a full blanket of the venting mat in the first place.
Okay, so a bit of a false economy. You may assume something is more expensive when it actually isn't.
Exactly.
Okay, great. Sue, another one regarding installation of something. So Robert has said he doesn't need ventilation under the BS 845 point system, but he has been advised to install a pressure relief system. Why would he need this?
Okay, so it is possible that you can achieve your required points with just, potentially your slab construction and the membrane that you're using. BS 8485 gives advice that you achieve your points from at least 2 of the tables within that standard. However, it is deemed to be good practice to incorporate some sort of ventilation. So although you might not need full ventilation to actually comply with your points requirement, it's good practice even just to install a pressure relief system, which can actually give you an extra 0.5 point. And a pressure relief system is really just designed to reduce the build-up of gas pressure below the slab. And just basically helps your gas system become more effective. And this can just be simply a few strips of the Pro Void with a couple of vents, and that, as I say, that will give you your additional 0.5 point, but also will give you a more robust system in the end anyway.
Thank you, Sue. Paul, if I can come back to you, please, for one from Eli, which is around what verifiers find is the most common reoccurring issue on install. So, i.e. corner detail, pipe penetrations, accidental damage, workmanships. So what do you find is the most common, reoccurring problems on site?
I would say one, or the most damaging, let's say. I mean, internal corners, external corners, pipe penetrations, you can put those right. That is us called in far too late. Like the steelwork's on, and you can't validate a membrane when the steelwork's on, or the protection board's covering it all. So you say, look, please, can you take up all the protection boards because we need to validate. Or they've got 16 concrete wagons waiting to pour concrete. And you say, well, can you come in and validate it, please? So I would say sequencing it's one of the most common things, but it's the most dramatic because obviously it's just too late. The other items such as internal corners, as they say, laps and repairs and stuff like that, they can be put right. Yeah. But sequencing that's a nightmare, is that?
And so have you had, just for my own interest, have you had scenarios where you've come to site and it's just too late and they've had a lot of expensive remediation that they've needed to do?
I would say we have about 2 or 3 a week.
Oh, gosh. So education is the way forward. I mean, I think that's a really good point about, the sequencing of how things are done on these sites.
It's the education part of it. It's not that site managers are doing it wrong on purpose. It is, they don't actually know the ramifications of it. And that is a big thing. And I mean, CIRIA are putting together a site guide now for site managers to hopefully alleviate this. But it is education of these guys that they don't fundamentally know what they are doing wrong. And I mentioned in my presentation program, I mean, I was a site manager and you are screamed at to get this done and this done and this done. And, it's sequencing is the big thing, sequencing.
Yeah. Okay, and one more for you, Paul, if okay. Michael has asked, so following a successful verification of a housing plot with the exception to service pipes, would these service pipes be verified at a later date, or could we simply send photographs?
We have a methodology where all the service pipes, let's say if you take housing, typically what you have is you have the water that comes through. They will put it through a drain pipe as much as anything. So they're okay. The soil and vent pipe, they're all sealed typically. So you've got one service entry in a house, which is the water pipe. And what we do is we attach a sign to that pipe. So please do not beware, this must be signed off at a later date. Please do not take this sign off, etc. Now, there are various ways to seal that. You can, an MVQ2 specialist would seal it with gas-resistant self-adhesive. You can fill that up with a closed cell foam, which is another way of doing it. In the I keep going back to the pre-verification plan, but the pre-verification plan will identify what material they're going to use. And if it's easily applied, then we would work with the site manager and just take CQA. And we would identify, as long as we can identify that plot that he's in, and say, well, look, he squirted foam in there and closed that particular service entry in, service entry off, then we would take CQA. Okay. When we visit site back at site, if we found that things weren't right, then no, we wouldn't take CQA. So there is various checks that we can do.
Okay, good, thank you. That's great, Paul. Coming up to the sort of last 3 or 4 questions. So if you have any more, please email them to webinar@proctorgroup.com or post them on the YouTube feed in the next sort of 5 minutes while the other questions are being answered. So Chris, I'm going to come back to you, please. Isaac has asked, why is radon covered under another standard that appears to be less stringent compared to guidance for methane and CO2?
That's another great question to ask, really, to be fair. And that's something that the industry as a whole is kind of questioning as well at this moment in time. The jungle drums are starting to beat a little bit, and in particular the Radon Council, which we are now a member of, and the BRE are actually in talks to look at revising the current radon standards. The last time that they were revised were back in 2015, and in all fairness, you know, there is lots of elements in there that we feel as an industry that do need revising. And we mentioned in the webinar before that radon is actually one of the biggest killers. You know, I suppose we like to call it the silent killer, a bit like carbon monoxide, you know, and really, as a result of that, it should be brought in line with the likes of BS 8485 with regards to, you know, independent validations, you know, train people to install them, because if they kill more people than potentially methane and CO2 does, why isn't that already sort of happening? So yes, I would agree that the methods in BRE 211 are less stringent, and I think that it's something the industry has recognised and watch this space, because I you know, it will be revised and likely to be in line with standard, you know, CO2 and methane protection in the near future.
Good, agreed. Good, Chris. And a good one for you as a technical sales manager. Harvey has asked, what is an average square metre cost for your gas membranes, and what is the availability?
Ooh, I can't give sensitive information like that out, can I, Keira?
I was going to say, I did see a couple of competitors posting questions earlier, so I did wonder, but it doesn't appear to be one of those. So,
I mean, obviously the membranes do have a square metre cost, to be fair, but I think what we need to sort of look at here is the bigger picture. You know, it's not just a membrane that makes up a system for gas protection. You know, there's the ancillaries, top hats, you know, DPCs, tapes. There's all sorts of things that should be added together to complete that cost. So it can be a little bit of a sort of false economy just to say, give us an indicative square metre age cost, because, you know, there are other things included with it. I think the other thing as well is to point out is that people get hung up a little bit about cost with gas protection, and yes, whilst that's important, I think the thing that we have to think about as the primal issue is making sure that the gas membrane is the right membrane for the right application, for the right types of gases, and I think that's what we should be looking at more as a company, as an industry, is making sure that the product's fit for purpose rather than just thinking about what a square metre rate is, if that makes sense.
Great. Okay, Pam.
Obviously happy to discuss that with him if he's got any projects and he wants a quote or prices, then we can obviously discuss that.
Yeah, so you've taken the fifth on the square metre price, but to be fair, we do have a lot of different gas membranes and they all do different things. So yeah, absolutely touch base with us afterwards. Pam, just a couple of last questions for you, if that's okay. Oliver said, we've seen your vented design on a drawing, i.e. a 2-day layout, but would like to understand how this is terminated with the various components at the perimeter.
Oh, that's a good one. It can be quite difficult to visualise sometimes how they all go together. And I did think, we like our props here. I did think about trying to go up to the factory and pick up a few bits and pieces to bring here. But as you can see, I'm in the living room and I thought I might be lynched by the family if I suddenly brought in a whole pile of sort of metre wide venting strips and things like that. So I'm afraid I didn't. And then I thought I might do a Blue Peter and make some out of toilet roll tubes, but unfortunately didn't have time. So we have a really good brochure with a lot of photographs of all the different components going together. So it does depend on what your requirements are on site, whether you're using a full blanket or strips. So we have slotted pipes, 110mm diameter pipes that have got a groove cut in them. Your Provoid slots into that gathers it. Now that could be full lengths or just slotted tees, depending on whether you've got strips or full blanket. They then connect into pipe work going through your wall and either connecting to a gully vent box or one of our slimline ground level boxes. Or there's an adapter to then take it to a periscopic vent if you're using that. We've got some good videos online. Our marketing team are excellent at doing the graphics, etc. We've got something for everything depending on what you want to do. So I think the simple answer is, again, get in touch with any specifics. We'll have a look and advise accordingly.
Good. Okay. Thank you, Pam. And last question, as far as I can see, from Paul, we often get involved in existing buildings and wondered, how do you seal the gas membranes at the existing wall junctions? I think we had a similar one earlier, but...
Yeah, there was, and certainly Paul touched on the new CIRIA guidance, the 795 document that's just been come out. I mean, historically, we just kind of like seal it the best you can. People forgot that gas protection isn't just for new builds, that you do sometimes have to put it into extensions or change of use buildings, etc. But it was always very, very difficult to achieve, especially if you've got like a solid wall. There's no way of taking it across the cavity. So it really was a case of trying to seal it as well as you could to the wall, possibly raggle out a groove to bed the membrane in and then mortar it in. But it has been quite rightly identified by industry that that's not a robust and this best you can attitude just really isn't the best way forward. So, as it's been touched on, and Proctor sat on the committee as well, CIRIA has produced a quite substantial guidance document on best practice for remediating existing building. So, yeah, it's really important. I would definitely commend that document to you if you've got sites where you're going to be sort of joining in with existing buildings or properties.
Great. And sorry, Pam, just not to disrupt the flow, I missed one earlier on the chat feed from Carl. I'm not sure if we've covered this in the time period since, but on NHBC Traffic Light System Amber 1, does the installation need to be verified? Is that one you're aware of the answer to?
My understanding on the level 1 is there's not really any specific requirements for any gas protection as such, so it's more defaulting to your damp proofing side of things. One of the guys might correct me if it needs.
Would I be right in saying there, Paul, that for all new NHBC homes, there does have to be some sort of verification, although I think more for sort of Amber 1, because it's the less risky, they do have to be able to produce photographic evidence and things. But does that, I don't know if that means actually need to have a specific verifier in to do that. I think that's just when it gets to sort of Amber 2 and the risk gets higher. Would I be right in saying that?
Amber one is this particular area which is causing a lot of confusion within the industry, because Amber 1, it does fall into CS1 and CS2. Now CS2, obviously you need verification. So this is local authorities at this particular stage, when the information is submitted, they will ask, where is your verification? Well, we're following NHBC guidance. Well, local authority overrides NHBC. So there is a bit of confusion there. Now, it does change from NHBC area to NHBC area, and also the NHBC inspector, because they will say, well, I want verification. Some will say, I don't. The guidance document that NHBC have, I think it is audited CQ or audited photographs, or photographic evidence that is in some kind of way structured, which I would agree with. Any verification company that would sign off a complete site that is not their site and that it's just photographs taken, I would say they're taking a very, very high risk. But at the moment, if you read the documentation or the guidance from NHBC, you do not have to verify Amber 1 sites, which I think is a little bit, needs to be looked into a little bit more, does that one. You can often identify in a site investigation report where it will identify in there that verification is needed. It is another source of information. And sometimes in the planning conditions, they will ask for verification. But what we're finding is that sometimes we will verify plots under NHBC guidance, which is a percentage, and then they will ask for a certification for the plots that we haven't validated. So you have to put in a system in place, which is, again, audited CQA. So, yeah. To the letter, you don't validate. You don't validate Amber 1, but you do.
Yeah. Sorry, Chris. Go ahead. Did you have another comment on that?
I was just going to say that it's sort of. I'm a little bit confused with NHBC stance on that. I mean, if you look at NHBC stance when it comes to waterproofing, they're very sort of risk averse and very, even things such as 600 mil below ground, they would class as a high risk from a waterproofing perspective. Yet the British standard obviously calls for the 2 points within the membrane to have it, validated under CIRIA 735. So I'm surprised that NHBC just don't adopt that as a method for all, Amber 1 and Amber 2, really, I suppose was what I was going to comment on.
Okay, thanks, Chris. Paul, sorry, just at the end of your comments there, you talked about validation after if certain plots aren't verified. In terms of checking. So Michael's actually asked a question very relevant to that, the last minute here. Some housing schemes only require a percentage of plots verifying. How would you ensure the site staff provide evidence that the remaining plots meet the requirements as per CIRIA 735?
Well, I mean, I can only comment really on what GeoShield do, but GeoShield, we provide training to the whichever level of management that they want. And so what we do is we issue a form which they print off per plot. It's a tick box form to say, okay, well, they've applied the membrane, they've done it internal corners using gas resistant self-adhesive or preformed corners, they've taped the laps, it's a block and beam, etc. So it's just a series of tick boxes is the first page. On the back page, there is the number of photographs that they need to take, which per plot, which for us is 16. So that is an overview front, overview back, photographs of the seams, photographs of the door application, pipe penetrations, internal corners, etc. So there's a full catalogue of photographs. That is then signed by the site manager. He then fires that over to us along with those plot photographs. That is audited CQA. That's the only way that we feel that if something does happen and the NHBC or the local authority say, well, we want evidence that that is installed correctly, then, we train them to do that. I mean, in my early days, I used to see them where they laid a gas membrane on plot 1, we'd disappear. They'd lift up the whole membrane and put it in plot 3. I mean,
That's not good for us either, Paul. As manufacturers, that's not great for us either. Yeah.
no, it's not. You've got 100 plots, and they've only used one piece of membrane. But so this audited CQA is where the plots aren't done, or the plots aren't valid or verified. Then it can be well structured. It can be, yeah. So I hope that answers.
I'm going to remember that analogy when my sales figures are down. That's the reason why, Keira, because they just keep moving these membranes on different plots.
No chance. Good. Okay. Well, thank you very much, guys, for your answers. The Proctor team, and Paul, thank you very much for coming along as our special guest. You've got such good experience and a wealth of knowledge in the verification side, so it's been really helpful to us and to our attendees. And thank you to the attendees. Thank you. Thank you to our attendees for coming along on this snowy day in Scotland. As always, if we don't have an audience, we wouldn't be doing these live Q&As. So we really appreciate you being here. You will receive a follow-up email. We'll receive a follow-up email, which will have a link to all the information discussed on this webinar, and you can also visit our webinar page, so www.proctorgroup/webinar. So you can download your personalised CPD certificate, you can request a sample pack about these products, you can ask for a Zoom meeting with one of our technical sales staff, Chris or the ladies here, plus all the others who are currently working from their home offices. And you'll also receive in the email sent to you a replay of the webinar. So please feel free to circulate that to any friends or colleagues that you feel may find it of interest. So again, our next webinar is in 2 weeks, Friday at 10 a.m. on the 26th of February. So Friday the 26th of February at 10 a.m. So please diary it if you can come along. Completely different topic, completely new topic. So it is spinning the golden thread, data management and data quality, which I think is going to be extremely interesting. So we'll be joined by 2 individuals, Mark Williams, who's the DAO CEO, and Jodie Davies, who's the media master at Twindit. And essentially, Twindit is a platform which they'll go through on the webinar, which really is to do with data management and distribution. And essentially, it's being utilised at the moment for use, helping local authorities and councils navigate, through, in terms of data, the use of high-risk residential buildings. So there's a lot of new legislation that's coming out at the moment in terms of how these councils are able to manage the data moving forward. So updating the digital twin with the physical twin, and just making sure that the key stakeholders, such as the asset management teams and emergency services, are quickly able to access all this building data as quickly as possible after the tragedy such as Grenfell. So it's a really moving landscape at the moment, and there's a lot of interesting digital innovations coming out. So they'll be going through that, and we'll be going through, the Proctor Group will be going through the Construction Product Information Code, so introducing that along with some of the manufacturer testing and data obligations. So it's all really interesting. So please join us 2 weeks today, Friday the 26th of February at 10 a.m. You should be able to register now on our webinar page as well. Please give us a thumbs up on this video and subscribe to our YouTube channel. It really helps us with, again, reaching out to a new audience. And it also means that you will get updates as we put new content onto YouTube. So I think that's it. We'll hopefully see you next week. If you have time to complete the short survey that's sent in the email to you, please do. We read every single one. I read every single one, and we often use it to help shape future webinars, how we can do things better. We won't be offended, be polite, but we're really keen to learn, what's good and what could be better. And wishing you a lovely weekend wherever you are. And thank you very much. Thanks, everyone.
Thank you.